Okay, number one. This is number one in the homework. So they have, well, I guess they have two parts. Say, fill in the blanks. Part A, log 4 of 7 plus log 4 of 3 is equal to log 4 of what? All right, so whenever you have a sum of logs, you can use property 1. If you have a sum, you multiply the inside. Okay? So what's 7 times 3? Yeah, so our answer will be log of 21. So all they want us to do is practice the properties. Okay? Any questions on part B or part A? Yeah, let me see if this helps. Is that a little better or no? Yeah, so they have to have the same base in order to do this. So fill in the blank again. Base 7 of something minus log base 7 of 3 is equal to log base 7 of 5/3. So this is the rule number 2 property. So what do you think this has to be? And it's supposed to be a 3. Right, this is this one right here? Or this is log base 7 of 3. Yeah, maybe if I zoom in a bit, that better? Or no? So look at this one. Look at number 2. X and Y, if they're being subtracted, log base B. This is supposed to be a subscript, by the way. It's not in front. I just can't write. Log base B, X and Y. If you subtract them, then the X goes on top. The first one goes on top. The second one goes on the bottom. So if we're going backwards, right? 5 and 3. So which one goes, what goes in here? Yeah, it has to be, right? So if you have a difference, you can change them into a fraction. If you have a fraction, you can separate them into a difference. That's what property 2 lets you do. Any questions on A or B? Okay. So we're not solving anything. We're just trying to apply the properties that I wrote down up top, or the ones on the formula sheet. So log base 2. So if you have a number in front, what does rule number 3 say? Right? And you can bring it up top. So if I have a number here, I can change it into a power there. That makes sense? We're just applying the rule. And then that becomes a ninth because of the negative power. Any questions on number 1? All right, let's go to another one then. If you do, let me know. So this time, let's look at the question. Can y'all see the question here? What's this guy gonna be? Yeah, for sure, 55, right? Okay, then what goes here? Yeah, it'll be the 3, right? And then this one lets me bring the power up. So what would that be? What's 2 to the 2? So any questions on how we're applying the properties, right? This product property, whenever you have a sum of logarithms with matching bases, lets you multiply the numbers in here. Or it don't have to be numbers. Whatever's in there gets multiplied. 11 times 5 is 55. This and this are coming from the subtraction, right? That's the product. That's the difference or the quotient rule. And then this one goes here, which makes it a 4. Any questions on number 2? All right, let's move on to something else. So here we're going to expand it ourselves. Okay, so if you notice that there's no number on the base, it's assumed to be 10, that this is log base 10, the common log. Here we have products, right? A product of x to the fourth times z. So what does the product property say we can do with the products? All right, number one says if you have times, whatever's in there can be changed and expanded into a sum. Does that make sense? You separate this into a sum of the same base. Now, how do we deal with this for? If you have a power, what can we do with the power? And so if you have a power, whenever they say expand, you want to do as much as you can and see if any properties still apply. So here, if it has a power, oh, not that one, this one, number three, you can bring it down in front. So just bring the power down. That's all you gotta do. So this becomes 4. And that's it. That's as far as we can go. So here we did product rule. Here we did the power rule. Oops. That's how they get this. So product, quotient, and power. First, expand with a sum or product rule into a sum, and then bring the power down with the power property. Any questions on this problem? It's not too bad so far. Yeah, just let me know if it's weird. As soon as we finish this section, we're gonna solve equations, and that's gonna be a little harder. So if the properties don't make sense, let me know. Okay, so it's log of, oops, a little blurry. Okay, so this log of x over y to the seventh. So what would y'all do first? All right, we want to expand it, and it is base 10. So what's happening inside the log? Yeah, since it's division, since we have a quotient, we have to subtract, right? So the top one always goes first, minus the bottom one. So that's quotient rule. Now, you gotta make sure we're done. If you see anything else, we gotta do it. What else can we do here? As soon as whenever you see a power on there, you gotta deal with it. Because when it says expand, you want to make it as you want to expand as much as you can. Basically you want to make it look more complicated. So apply a new property to make it bigger, more complex. So if it has a power, what do we do with the power? This one has nothing, so we're good with this first part. Yeah, just put the 7 in front, right? And that's it. There's nothing else that can be done. So we expanded it, and then we brought the powers down. Okay, and that's it. Nothing else we can do. This next one is a little harder. Use the properties to expand. So this looks really funky, but you should start with the quotient, right? We see a division. So let's just separate them and then go from there. First top part minus the bottom part. Okay. So everything at the top minus everything at the bottom. Now we should know that the cube root is the same as a power. That was quotient. So before I do anything else, I'm going to rewrite it just in case you're a little rusty on the algebra. Cube root is the same as a 1/3 power. Oops, forgot my tooth. So cube root of these two things is the same as those two things to the third. The z has a square, the x does not. You guys are still with me on this one? Okay. What do you think we should do next? Yeah, you see the power, so let's try that out, right? Yeah, this one has a 4 on it, and this weirdness has a third on it, so we could pull the third in front, we could pull the 4 in front. So let's apply our power rule. Is that okay? Right, so this one, do you all agree that it's done? There's nothing else we can do with it as far as expanding goes? I mean, the first part. We're good on the first part, right? This little 4 log y. But this one has some stuff going on inside. What do you see on the inside? Yeah, there's two variables, and what are they doing to each other? Yeah, so we have a product, so we should do the product rule on that part. So little by little, apply your properties. It's just like a weird game. I'm gonna put a big bracket just to separate the third, because all this will be this third is on everything that's gonna come out of this. You see what I mean? Just to try to keep it neat. You guys still with me on this? All right. The one we just did from here to here is a product because we changed the product of x and z squared into a sum. So there's nothing else I can do to the log x. What can I do to the log z squared? This guy's also done. Yeah, we gotta deal with that too. So that's the power rule. Now we're expanded as far as we can go. Only thing we can do now is distribute that third, and that's it. So multiply the negative third on both, and we're done. Negative one third times that is negative third log x. Negative third times 2 log z is 2, oops, minus. And that's it. Is there any steps that didn't make sense? So the beginning, we separated into a quotient, right, using the difference, subtraction. Then we changed that cube root into a third so we could deal with that power. Brought the power in front, brought this power in front. Then we dealt with this product, got these two pieces. And then we dealt with our power, brought it down, and then we multiplied the negative third on both. We got these two. So that's as far as we can expand it. So instead of having a single log, we have three of them. Is there any questions on this one? This is a little harder. Yeah, we're just distributing the third, that's all. Correct. Yeah, let me show you this. Let me show you one without working all of it out. And just so you can see one more example. So this one has a square root of x cubed y times x cubed times y times e to the fifth. So this is three products, right? And it has a power on the whole thing. So the first thing you got to do is change this square root into a half and then bring it down in front, right? Then they say, okay, well, we have a product of three pieces, so it turns into a sum of three pieces. Then whatever has a power is then brought down. They brought the 3 down. They brought the 5 down. This 5, this 3. And then you distribute that half that came down from here to here on every single one. So this one, that one, and so forth. You see what they're doing? It's similar to the one we just did. Although this one I think is a little easier. Let's do something a little different. So now we're going to put it back together. So we've been expanding them. Let's put them all back together. There might be, but it'll be the same. Just treat it as a power and then bring it down. If it's a cube root, fourth root, square root, just remember, whatever root it is, that's the fraction it's going to be. So if it was fourth root, you'd have a 1/4. All right, so here we go. Log base 7 of W plus 3 log 7 minus 2 log 7 of Y. Okay, so this looks kind of disturbing. So 2 log 7 W plus 3 times this entire thing. Inside we got log 7Z times minus 2 log 7Y. Uh, we should always, so if we're going backwards, remember the last thing that we did was bring the powers down. So now it's going to be the first thing we do because we can't do the products or quotients until the powers are up. All right, so first thing, let's look at this part. What should we do to the first piece here? Yeah, let's bring up the 2. So that'll be W squared. Okay. That part is done for now. I can't do anything with it until I deal with this parentheses. Okay. This guy has no power in front, so I guess it's good. But this one, you see it's going to be Y squared, right? Yeah, cool on this part. Okay, so now you see subtraction inside. So what can we do with subtraction? I can't deal with this 3 just yet. This is better to deal with this first. And I guess you could distribute 3, but I recommend dealing with everything inside first and then deal with 3. Well, let me think about that actually. Would that, you know what? I think it would have been easier if I distributed the 3. I'm wrong. But let's wait on this. Sorry about that. I mean, it would have been fine. There's nothing wrong here. Just let me start with that. But if I do it this other way, it'll be easier. And I don't want to confuse you. Technically, we can keep going the way it was. Oops. So distribute your 3, so I was wrong. This is better to distribute first. So we can just bring up the powers. So now we're going to bring up the 3 and the 6. Because if I bring the 2 up first, then the 3, then I have to bring up the 3 and then multiply the 2 up here, which I think is a little more strange than just doing it this way. But again, if your algebra is awesome, it doesn't matter. But I feel like if it's not, then this is better. Bring up the powers, bring up the powers. Okay. Y'all still with me up to this point? That's a good question. It doesn't matter because it will end up being the same. So we can add these two and do the product and then deal with this, the minus part, and do the quotient, or we could do this as a quotient and then deal with the plus. Does not matter. I'm going to combine these just because. No reason. Now I have a sum of two things. So we'll multiply this times this for the product. Technically, this is over 1, so I'll show an extra step just in case your fractions are skills are a little rusty. Okay, let's start from the beginning. First thing we did was bring up this 2. Then we distributed the 3 onto both. giving us 3 log 7 and negative 6 log 7. Then we brought those powers up. The 3 became a power, the 6 became a power. Then the minus became the quotient. Then this plus made these a product. If there's nothing underneath, it's understood to be a 1, so this was always going to be on top here. Is there any questions on the algebra or the properties of logs? Okay, let's do one more combination. Write the expression as a single log. These are all base A. So what would y'all do first? Yeah, so you deal with the always deal with the exponents first when you are combining. When you're expanding, do the exponents last. So no more coefficients. They're all powers now. Yeah, just a real quick reminder, right? So when we're combining the logs into a single log right now. So first deal with these and turn them into powers. But when we were expanding earlier, you notice how we brought the powers down at the very end. So that's what I mean. So if you're expanding, the powers come down at the end. But if you're combining, the power should go up at the beginning if you see any. Because we're going backwards, right? And yeah, this 1/4 is technically fourth root. That is true. In the algebra PDF, the nth root of x is equal to x to the 1 over n, where n is your root. So we could change it if we wanted to. What should we do next? Yeah, we got two sums, right? So here we did, from here to here, we did the power. Now, we multiply the arguments, the stuff inside. Now we have subtraction, so what do we do now? Right? This is the first part. This is the second part. So this is going to be on the top. So change it to a quotient, but put this stuff on top. Minus whatever's on the bottom. Or whatever's over here goes on the bottom. Okay. Now you could change this to a fourth root. I don't know what the answer is, but they might write it this way. But I would accept both. Technically, they are both equal. Yeah, and the homework they left it as a fourth, but both should be correct. Is there any questions on these steps? No, that's pretty much it for this section. The goal of the whole section is to understand and know how to use the properties when you need them. Right now, we're just playing with them. We're putting things together, we're breaking them apart, putting them back together. That's what we're doing. We're not solving anything. In the next section, we're going to solve things. So the next section assumes that you know all the properties or you're comfortable with them, which is not fair because we just learned them, right? We just used them. But that's how math goes. Yeah, we're gonna have actual equations. Right now we just had an expression and then we put it together. Then earlier we had something like this and we broke it apart. But let me show you the last two questions in this homework. I'm not gonna solve them because it's just a formula, but I want you to see how they do it. So check it out. So this is the formula you're gonna need. It's called the change of base formula. It's in the PDF I sent you. I didn't write this one down because it's rarely used, but you will have it in your homework and you might have one on the test. But basically what you can do, it is useful though. I mean, if you have a single log with the base A and B, so these little A's and B's, you can change it to any base of your choosing as long as you put the B and the A here and here. This B and this A. The C is your choice as long as these conditions are met. You're good. So check it out. I have log base 8 of 1/6. I could change it into log 10. This is a 10. So they chose the common log. They put the A right there. They put the B right there. And then they put it into a calculator. That's all they did. Because the calculator has base 10 and base E. They don't have, unless you have a nice fancy calculator, they don't have a base 8. So if you need to actually find the number, the approximation, the decimal, you got to use this. The base is whatever you want it to be when you use this formula. Okay. But yeah, that's pretty much it. But any questions on this section? I'm gonna move on to solving the equations. Yeah, and if you haven't seen the videos I sent, just watch them when you get a chance. It goes into the definition of the exponential and the logarithm, and they talk about what the bases are. Like we don't need them to do the mechanics, but you should understand them if you haven't read about them yet. Alrighty, let's move on to, oops, crap. Let me try to stop the